Hi Tom, it's Sean here, your tutor for maths. So this is that question during you asked me about the marble pyramid. So I'm just going to walk you through how to do this question. It's a difficult question, so if you can do this question, I'm pretty sure you will get full marks, and I'll be very impressed if you manage to get this question correct, and you deserve to be very proud of yourself if you get it right. So I'll talk you through it. Firstly, if you're looking from the side of the pyramid, remember you told me that there's three marbles lined up on the side, and each marble will contribute a total of 0.5 centimeters from here to here, because that's half the radius. And you got a 0.5 here, a 0.5 here, another 0.5 here, and a fourth 0.5 here. And you told me during this afternoon that the total of each side is going to be 2 centimeters when you add it all up, and that's correct. So you know that each side here is going to be 2 centimeters in this triangle. If all the sides are equal in a triangle, we know that the triangle is an equilateral triangle. So what do we know about equilateral triangles? Well, if you remember in your textbook, you should have read somewhere that equilateral triangles have equal angles. That means that all their angles are the same. And for an equilateral triangle, the angle is going to be 60 degrees. And each of the angles. So that's the basics of it, and that's really important for this question. So remember there's 60 degrees in each of those angles, and you've got each side is 2. So let's have a look at a picture of what the pyramid looks like. So here on the picture, here's your pyramid, triangular pyramid, and you're trying to find the height right in the middle here. So don't worry about this part here, I'll explain that a bit later. So what you've got is each side is 2 centimeters as you found before. So they're all 2 centimeters. What you want to try and find is the height. So you need to try and find this red line that goes right through the middle of the triangle. So the first thing we're going to look at is this big bottom triangle down here to try and figure out what this red line is. So if we have a look at this big triangle down the bottom, that's the base of the triangle. So that triangle there is what's on the right over here. So we'll see that that red line is the L in the middle, that red line over there, and we know from before that each of the angles are going to be 60 and all the sides are going to be 2. Okay, to find the red line, we can use we got to figure out what the length of the L is. To do that, we can use some Pythagoras, which you learnt today. So with Pythagoras, you've got an angle here and a side here and another side here. So you remember that this side here is called the hypotenuse, that's the H side, and then you've got this side here, which is the opposite side, the side opposite to the 60. So remember, we're looking at just this half of the triangle here, just this triangle. That's all we're interested in right now, because we're trying to find L. So one of your Pythagoras' laws relates your angle to the opposite and hypotenuse. And I'll let you figure out which is sine, cos, or tan. One of them tells you how to find what the opposite side is when you have the hypotenuse in an angle. So using that law, you can find what this L line is. After you've found what that L line is, we can come back across to this triangle, and now we want to look at the upright triangle, which is this triangle here. So I'm going to mark it out. This triangle standing upright, that triangle here. So we want to look at this triangle now. There would be somewhere in your textbook, which is why we couldn't solve it today because we didn't find it, that tells you in a triangular pyramid prism like this, or a regular tetrahedron, that the middle point is actually 2/3 of L. From here to here is 2/3 of L. So you'll need to take the L that you found before on this side, and you'll need to figure out what 2/3 of L is, because you want the distance from here to this right angle right here, and that's 2/3 of L. So once you have this distance here, the 2/3 of L, you now need to figure out what this angle is in here, because you need this angle to work out what H is. So you want to work out this angle right here, from the red line to the black line. And that angle, we have no idea what it is. It's a question mark. So we need to work at that angle. To work at that angle, again, we need to use our Pythagoras again. So from our Pythagoras, we've got an adjacent side and a hypotenuse side. So A and H. one of your laws again will relate an angle to adjacent and hypotenuse. So you've got to think about which one that is and use that law. And so you've got a distance here and a distance here, and you're trying to figure out this angle. Now I'm not sure if you've learnt already how to do the opposite of sine, cos and tan, because the opposite of sine, cos and tan is actually on your calculator. There's a button that looks like this. It says sine -1, cos -1, or tan -1, and it lets you figure out what the angle is. So if you've done it before in class and you know how to do it, then go ahead and do it. If you don't know how to do it, I'll tell you this angle just in case you're not sure how to do it. So the angle in here is actually, let's see, the angle in here is actually 54.9 degrees. So that's that angle in there, in case you're not sure how to do that on your calculator or you haven't learnt it yet, because that's pretty important. I can teach you how to do that next week. It's very simple, but it's a bit hard for me to explain it over the internet. Okay, so if you have this degrees, you've got an angle, and you've got your hypotenuse, you've got an opposite side. Now you can find what this opposite side is, which is the height of the pyramid, by using one of your sine, cos and tan rules that relates the opposite side, the hypotenuse side, and the angle. And you can figure out what h is. And h will be the height of your pyramid, which is what the question's asking for. But the question doesn't end there, because remember, once we find the height in here, if we look back at our original picture, what you've found is you've actually found the height from this point to this point. That's your h there. So this line is that red h line that you saw before. So let's go with red. So you found this height. Now the question is asking you, what is the height of all the marbles? So that's the height, including this little bit up here, all the way to the top. This little bit, you know it's 5 centimeter radius, because these are the center of the ball. So you need to add a 0.5 in here to your height. Again, you also need to consider the bottom of the marbles, which goes all the way down to the very bottom of this marble. So you got to add this extra little height in. So again, this extra little height in you also know is 0.5 centimeters. So you need to take into consideration these two extra 0.5s in your final answer. After you found the actual height of the triangle, you need to add these two on, which will give you your final answer. And to give you a hint here, the final answer is somewhere between 2 and 3 centimeters. So if you can get an answer somewhere between 2 and 3 centimeters, you should be about right. And if you want to check, you can email your answer to me and I can tell you if it's correct or not. So good luck with that question. If you've got any problems, don't feel free to email me back and I'll help you out.